A very warm good morning to all. I am Manish Singh Bharti, Assistant Professor, Rabindranath Tagore University, Bhopal. Today our second session of today's workshop on skill on the topic of current and future trends in research and development domain in automotive industry. Before starting the session, let me introduce our resource person, Mr. M. Srinivasan is a Senior Research Associate and Design Engineer, AMZ Group, Jaipur. He has awarded BTech degree from Anna University. He has the vast knowledge and experience various design tools such as SolidWorks, CATIA, ProE, ANSYS, HyperMesh, etc. Now I request Mr. M. Srinivasan to start the session. Please, sir, start the session. Srinivasan, sir.
Sir, please.
Unmute. Yeah, sir. Start.
Namaskar, sir.
Thanks for the warm welcome, everybody, to all the panelists. It's good to see you this morning. So, this is Srinivasan here. So today, the complete idea is to bring out what exactly we do in R&D development. Right? It's kind of an awareness program that we are conducting for in collaboration with this particular university to bring up a light on what exactly happens in research and development. Right? So this will be much interactive session. So we keep interacting all through the course. Right? And before getting started, do let me know if my screen and my voice is clear to everybody. So it will be great to start.
Yes, sir.
Yes, sir.
All right, great. So as I said earlier, the agenda is to bring out all the aspects that an engineering student he might not face in a 4-year undergrad, and to bring out a light on what are the trends and current market is looking for an updated engineer who's somewhere trying to pass out in 2021 or 2022, right? So we're trying to stick with that, and what are the information that we are giving is essentially from the source that we are relying on, right? So before starting up anything, I want to put a solid base. Everybody has to understand what exactly R&D means, right? Because there are a lot of misconception keep going on. People not able to get the right idea, right? So we'll first make it this point clear. R&D in India especially are completely different from anywhere in the world, right? So that too in our automotive industry, the products that we make, the service that we give is not same as anywhere in all over parts of the world, right? So bring that clear, right? So what does R&D means? So R&D means irrespective of, it need not be a car or a component, any component that has to be revised over a period, it's obviously going through R&D, right? So here I've given a simple example that will actually walk you through the process. So what happens when you actually work in development processes, you get a scratch design, right? So say somebody who's working in a design engineer and he has to put some energy on releasing the design. So he will be the owner of a design, right? So this is something like a scratch that we made up out. So you see a 2D model here towards the right. If possible, I'll try to annotate. Yeah, so I think you could see the very first scratch design. So what usually happens is you try to innovate something, or you try to make out any product from scratch and you draw it. Essentially, nobody is going to use any CAD software or a tool, be it any software. No, there is no essential of using them. You draw it, you draw with your all the future sketch that you're managed to get it out, right? And then you convert that 2D drawing into 3D space, right? So then you get so much of get to know with a lot of design aspect, and because you're looking in 3D, right? And then you convert it and give it to a CAT, right? So in an automotive industry, it starts from the design and it moves to the CAE. So what is CAE? It's a computational aided engineering where you do real-time testing, you perform finite element analysis or multi-body analysis depending upon what scale of project you're working on. But essentially, you're trying to simulate how the vehicle behaves on road or practically, right? Why is that? Why it's so valid? Because every automotive company has to pass the CAE test before getting to manufacturing, right? So to be clear, you start from the design. The design engineer will only design the component. He never do anything apart from that, right? Then it goes to CA team. So now the CA team has to certify the product, whether it's durable or not, whether it's reliable or not, right? So we spend, say, I'll give you a random idea. The Toyota Ilrex is a one car that most of the engineers know. This one car to get it to CA, 10,000 engineers worked on that particular car to make sure it's validated in that process, right? So in a typical company, be it Maruti, Mahindra, any company, there will be somewhere between 500 to 600 design engineers working on them, and 200 to 300 CA engineers working on to finish the product, right? So it's not done. So you design it, you simulate it, but it's all done in virtual, right? You're trying to be as close as accurate you maximize your accuracy of possible, but still there is a lag, right? So you can't validate your model 100% by doing a computer simulation, right? Even though computer simulations are gaining so much of control towards automotive research and development, but still a traditional method will give you a final flavor of what's happening here. That's what we call it as a physical testing, right? So physical testing, the one another thing that physical testing is so important is it's directly intuitive. So what does that mean? If you didn't do your process well, it throws the results in your face that this particular product is failing very badly, right? So you do a physical testing and you see all that you have spent the money on design, CAE development, is it worth or not, right? There are a lot of companies out there, they don't even prefer CAE. They don't actually simulate in computers. They finish the product, they manufacture it, and they directly move on physical testing. So that kind of reliability we can expect from physical testing. But one other problem that we have in physical testing is expensive. It's quite expensive because just think of this way: you're making a Tesla car and you're making a three product. You want to see which is highly durable. The only way to do it is by distorting it. It means that you are already spending way too much on physical testing, and that's why companies prefer who's good in CA or who have knowledge in CA get into engineering division. Clear? So it goes hand in hand. You want a guy who has to understand the physical testing and to perform the simulation. So that's how the entire product works, right? Be it developing a component, a rod, to a full-fledged car. You design the component and you give to a simulation team, and then it's simulated, and you do a practical testing. Depending upon the size of testing, you try to maybe simple test, as I can example is like tension compression test to see what the material is behaving at the stage, right? So this is the entire process of any product development in any particular automotive segment industry, right? So that'll kind of give you what exactly the process that any company follows. Clear? So moving on, right? So this particular slide is put together to understand. It's not a kind of a nightmare. A guy develops a product or a team develops a product, right? So it's kind of a process oriented a field, I would say, rather than the concept oriented field. So what I mean by that is, say you have a chassis, one dedicated team has allotted to develop a chassis, and similar to suspension, steering, and tire, right? It's very easy to do it individual. So it makes sense. Somebody is given one particular job and they do it well, right? But what do I mean by research and development, and not development, we are developing it, right? So we have to put together, you have to put the steering, tire, suspension together. At the end of the day, it's all about how the driver feels, right? Your car maybe cost around quarter million or more than that. You have put together all the research and development in the car, but end of the day, you do some fanciful thing in your car, but your car fails to perform, then it means that you're just wasting your time. That's for sure, right? You're not sufficing the need of your customer. That's one other thing that keep remembering the thumb rule, right? It's not that what fanciful things, what technology you put in your car, it's how customers are satisfied. So there's a big thin line between what you do and what you get. So you want to keep matching that particular line, right? So what generally do is we try to bring it out chassis, steering, tires, suspension in a different format. At the end, once they are done, they are reached to a point where no more simulation can be done. We put together and make a final product, right? So a lot many problems will be there in the final stage where you're trying to merge two system, be it suspension, steering, or tire. You try to merge it out, and then you quite often do physical testing, which is the iterative process of the development. Clear? Yeah. So usually we try to target, we're trying to keep it simple and quite efficient. So we start with the process. I also already told you, we start with the process in India again. Uh, Depending upon the market that you're working on, usually I think 60% of Indian automakers research and development work basically is not for India. They're just outsourcing the product, right? So to be precise, most of the companies, they don't develop a product here, right? You see down south or uh, high in north, there are a lot of companies are there. Most of the companies, they do manufacturing. They never do research and development, right? So why is that? Right? So India is meant to be a Detroit of uh, all the automobile manufacturer you see. But what does that mean? People able to get the car quickly out of a manufacturing house. They're not able to develop. What are the design you see here? It's not ultimately given by the engineers here. Every design is coming from either Germany, mostly from Germany. Whatever the design that we do, everything is coming from Germany or US, right? So they're both domain where all that most of the research work does, right? So in case if you're working on a development process, say I'll give you one example. Like we have a FEA engineer who's working on ensuring the durability and testing process of a product, right? So the same work, same job, if you do it in a different country, the standard and the quality of a work completely stages different, right? So that's why I inevitably suggest all the people most of the time get a work experience from apart from India, because Indian automotive industry itself is quite different. The segmentation is different, right? It will take certain amount of a time, say I would say 5 to 6 years of someone to get an expertise, whereas if you're working on any other parts of automotive industry similar to US and Germany, you could get there from 2.5 hours easily, right? So second is going to be sustainable growth in PDC. What does it mean by that is product development cycle keeps evolving. It's not that we have a standard protocol. Uh, 500 people are working on design. They release the design with the authorization that they are the design engineers, and it goes to simulation and it comes back to physical testing. So it looks as a very simple process, but believe me, uh, I think everybody knows the latest Mahindra Thar. It took almost 5 to 4 years to finish the cycle, involving all that three, right? So design, go to simulate, and physical testing. It took for a particular car, Mahindra Thar new version, for getting out of the track for 4 years. So similar to that, any product that you put on, it could be taking a considerable amount of time, but again, it's quite worth it to validate the model, right? So the upcoming slides that we'll be talking about EV research and market trends. So what we're going to do is why EV is booming. That's a sensible topic to talk about. And again, market trends. What I mean is usually you tend to compare the US market trends to India. That's never is going to happen. You keep assuming, but practically that's not possible because India itself is having a unstructured way of approaching things, right? So to put it on very straightforward way, what usually happens here is the all around the Indian automotive industry, anywhere you see, their pattern of developing products and selling it is completely different from the India. So what usually happens is they develop a good product, sustainable product, and try to sell it out with a higher cost. But in India, what at the most matters here is the how cheaper is your product is, right? Irrespective of what field you develop, if you are selling the cheapest product, then it seems that you're going to be a hand above than your competitor for sure, right? So that's what I mean. The pattern is completely different from out of India and inside India, right? And then we're going to talk about autonomous industry, because that's another industry which is actually booming nowadays. And we tend to estimate that for next 15 to 20 years, you see a lot of development work. They already are in a stage where the driver has to no more manually operate things in a car. He has to only sit and just navigate where you want to go. So that one other industry, and it has its own pros and cons that we're going to talk about. And future trends on technological change, so that's purely biased towards machine learning and artificial intelligence, right? So a common misconception that I'll try to pinpoint here is machine learning, artificial intelligence is only for mechanical engineers. Sorry, it's only for people who study electrical, electronics, and stuff, right? Basically, circuit people, right? So now, now the rule is, as the wall has been destroyed, so it's also applicable to non-circuit people, right? So nowadays, what we're trying to do in industry is, what are the small process that we tend to do? We're trying to write a Python script or any automation script to make our work easier, right? Because end of the day, you want your life has to be easier. So machine learning and artificial intelligence is an inevitable part of developing a product in automotive industry. So I suggest everybody has to go with, at least not in a great coding skills, but you have to be great in your fundamentals, right? If that is the case, you will have some advantage over your other peers. Once being a mechanical engineer, you're still able to code in Python or MATLAB. That will be a one another advantage that you get from here, right? And finally, we are going to talk about career opportunities in research and development. So this is something that case specific. So case specific in the sense, depending upon which division you take, we have, I think, to pull it out very neatly, we have 15 to 20 division in an industry, right? So most of you guys, I think, aware of what is manufacturing, right? So to put it out straight away, manufacturing itself is not a development area. So somebody has given you a design, your job is to convert the design into a product, where you in between that you find a quality check, you find a surface check, all the check, but essentially you're not developing it, you're trying to convert the sketch into a product. Clear? So manufacturing is huge. I know that India, we have a lot of manufacturing plants in and around south and north. But again, engineers are meant to work on development cycle, not a repetitive process, right? So you keep having a chain in the loop in the manufacturing area, and all the time that you spend is going to be developing somebody's idea. So we're going to talk about what are career opportunity and mostly how to approach them, right? So a lot of people have a good talent in around college. They used to work on Baha, or they used to work on some good projects, have a technical knowledge. But the problem is there is a small gap between the industry need and your portfolio, right? So you have the pretty decent portfolio that anybody could have is a 4-year undergrad guy would have worked on 2 projects, 2 major projects maximum. And if he's excellently and good in academics, he might have done some research papers, right? So this is a basic profile that you could see in any undergraduate, right? But industry is not actually expecting that kind of profile. So I will talk about more in that segment. So that's the topic we're going to cover: how to bridge it out, right? How to bridge it out the need of an industry to your academic profile that you're getting from your college, right? Yeah, so frequently we'll try to have a stop, and I'll have a pass every maybe 10 to 15 minutes to make sure you be with me all through the process, right? So if there is any doubts that we could address, do let me know, or we can put it out in a comment up to this point. If there is no doubt, it will be great if you put no in the chat box and we can move on.
चैट बॉक्स में डाल देंगे, जिसको भी कोई डाउट है वो चैट बॉक्स में डाल सकते हैं ना. ओके फाइन.
Please, sir, continue.
सर कंटिन्यू.
All right. Great. Right. So this particular slide is going to actually explain what happens when everybody is going to use electric vehicle in India. Very simple, right? So as you can see, these are the random graph that picked up. So the one which is colored in a dark blue color, they are developed countries, be it Japan, be it USA, be it Germany, whatever they have, right? Which means that they have a much more good emission standard than India, right? So what I mean by emission standard is what are Bharat stage, what we call it as Bharat stage 3, Bharat stage 4, Bharat stage 5. It's not essentially derived from India. We're just copying the Euro norms. It's just copy paste of what German is following in their country, just copy paste of that, right? So what is a particular thing that you have to look at it here is, right now, what are the vehicles you see? Everything is BS4. Most of the vehicles that you see in India, they are BS4, right? So what if they're going to switch to BS6? What will happen, right? So that's kind of answer the question why electric vehicle is not due to, first thing, it's not due to the pollution, right? Just get this out of your mind. Electric vehicles are pollutant vehicle. They're not green vehicle, they're not eco-friendly at all, to a small percentage, but they're not completely eco-friendly. They don't actually pollute it. That's kind of a makeup idea. Clear? So that's the first point to validate. Electric vehicles are pollutant vehicles. So why I'm talking about this? Because where you're getting electricity, it's not everything you're getting from renewable resources. Only few percentage are coming from renewable resources, right? You run your NDPC, I try to burn the coal, excessive coal, again you're trying to pollute it. But this time you're doing it indirectly. You're not, in your houses near to the city, you accelerate your car, you see immediate smoke. That's kind of a, the false idea in IC engine, but still electric vehicles are a pollutant vehicles, but it's going to be indirect way of approaching, right? But your electric vehicles have a chance to get a clean pollution because you have an option to get into renewable resources, right? So you see here, this is a data given by Bloomberg University. What they address here is only very few percentage of source of electric vehicle is coming from renewable resources, say 30 to 40 percentage. It means that 70 percentage of electricity to run your car is actually coming from non-renewable resources. Again, you're just polluting the city, right? So that's the kind of idea why actually a companies have started switching to electric vehicle. So the reason is fairly simple, because right now we are in BS4, once you go around BS6, so the emission standard is going to be higher, which means that for a BS6 vehicle, if a car is going to travel 1 mile of distance, it has to produce only half kg of CO2. That's nearly impossible with the combustion design that you have, right? What are the money you put in a combustion design or develop a product? It's inevitable to come to a point in any ICE engine vehicle, you have to travel 1 mile of distance and it has to produce only half kg of CO2. And that's the reason companies are start switching to electric vehicle, because you can't do with that in IC engine. You can still ask me, sir, what if in BS6 we are going to make IC engine vehicle, right? So we're going to make IC engine vehicle that's not going to satisfy the rule that policymakers made, right? So in India we have policymakers who make the emission policy, right? So the each amount of excessive pollution, say 1 kg of pollution that the car is emitting, the company has to pay some amount to the government. Is that clear? And that's a point of validation. No company is ready to pay an extra penny to the government because of the pollution test that's not passed by the product. Clear? And that's why we have a product of electric vehicle everywhere moving around, because you can easily pass the Bharat stage 6 with this electric vehicle. 1 mile of travel, it hardly produces half kg, right? So that's the only way of addressing this electric vehicle. Now you see this all the way Japan, German, they have a much more established quality standard, but India, we don't have that kind of standard, right? It's quite applicable for them, but it's not directly intuitive for us. Clear? Yeah, so one another reason is so if you have two vehicle, one is electric vehicle and an ICE engine vehicle, right? You see a vast difference between them, right? So the first difference is the battery pack is going to be coming close to the ground, which is almost very close to the ground. So it's going to give you a good stability. Whereas your ICE engine vehicle, you see here, yeah, whereas your ICE engine vehicle, you have a huge amount of load acting in the front, right? You see very less load acting in the rear, but huge amount of portion of a load is covered by the front, thus giving you a straight line stability, but it doesn't give you so much good of performance in cornering. But whereas this is going to be a distributed way, that's going to give you high end performance. That's one thing. So as I said earlier, electric vehicles are polluted, but again, it depends how much of using your renewable resources and non-renewable resources. Yeah. So one other thing that exactly brief you about is weight to power ratio, right? So see, imagine you purchase a Maruti 800 car. The weight of engine is going to be somewhere near around 1000 kg, but the horsepower that it produces is hardly 200. 200 it's a maximized value, but again, we can quite assume that for ICE engine vehicle, the weight of engine is 100 kg, but hardly you can expect it to produce 200 horsepower. Whereas a simple compact motor can easily produce 2 to 250 horsepower easily. So why is that? You see, you call as an idling RPM. Whenever you start engine, you need an idling RPM to run the engine. If you don't have it, your engine eventually die down, right? The biggest problem here is only ICE engine is quite efficient in this RPM. You would have seen it. Whenever you start a car, you try to move it out, ICE engine is giving you very poor performance. But when you go around 3000 to 4000 RPM, you achieve the range, which is quite efficient, because you see the curve is actually kind of flattening here, but that's only for a limited range. You can't stay in this range for a so long period. You have to anyway try to replace your gear, get into the next RPM that you want to go, right? So that's a only poor way of addressing the power in IC engine. You don't have a consistent amount of, see the graph, it's actually rising and it's getting a saturated region, again it's coming back, right? So that's the only drawback in IC engine. The power is inconsistent, clear? But whereas you have your electric vehicle, that looks something like this. It's quite good to assume, but it's not actually a straight line. It's almost a straight line. Invariably, depending upon variation of a torque, say you're traveling on 10 kilometer, 20 kilometer, 100 kilometer, almost the torque given by the motor is same, right? So that's kind of a managed whole thing. If you have a drag race between electric vehicle and ICE engine vehicle, the torque given by electric vehicle will be much far in ICE engine vehicle. That's why people prefer, getting the torque higher. And if you feel that torque, you know that electric vehicles are far more than ICE engine vehicle. That's one another thing that give advantage towards electric vehicle. Yeah. So in industry, what usually we do is it's really impossible to go with fully electric, right? So what I mean by fully electric is the range that you're getting, the kind of a range and mileage, power, everything that you're getting is always incomparable to hybrid vehicle, right? So if you just ask me a random question, right? So is it electric vehicles are good or ICE engine vehicles are good, right? I would say hybrid vehicles are most efficient than both, right? So the kind of a performance, mileage, range, everything that you're getting from electric vehicles can be still optimized to a hybrid vehicle, right? Because in a hybrid vehicle, you have a two power source. If one is not working so well, you can actually go around another one. But the only problem is it's quite expensive because you have two powertrains. Whereas electric vehicle, you have a battery pack and a motor, and that's job done. You don't want to worry too much on that. But you'll be having a range issue and a performance aspect. You can't mount too much of load on it. That's one another thing that you have. But usually we try to classify the cars into three different categories. They start off with mild, full, and plug-in hybrid, and fully hybrid, right? So depending upon how much bigger you have alternate powertrain, be it size of a motor, size of a battery, you can call it as mild hybrid. Scorpios are made up of that. Whenever you see you beat in a signal, your engine automatically switch off without you switching off. Engine will automatically switch off, right? That's kind of a mild hybrid technology. Full hybrid is initially for moving scenarios, you use electric vehicle. You use motor for powering your wheels. Whereas once you keep forwarding your, once you keep on trucking up more than 50 kilometers, 60 kilometers per hour, then you're good to go with your IC engine, because everybody knows that electric vehicles are good in giving the torque at the initial stage, but IC engine are good in cruising out. So cruising out in the sense, it's good in the range of RPM between 3000 to 4000. You can't go less than that, you can't go more than that, right? So what we're trying to do is, we're trying to get the two disadvantage part of two powertrain and merge it together and get an effective powertrain here, right? That's why you see, I think 2 to 3 years back in 2015 to right now, almost the development process is more on hybrid vehicle, not so on electric vehicle, right? Specifically in India, a lot of people started working on hybrid powertrain, developing two different powertrain. That will actually give you a more performance than any other vehicle here, right? But the only problem in the hybrid electric vehicle is, again, you have to use petrol, crude oil, which is not in your, the control of cost is not in your hand in India specifically. Or the rise of petrol is not going to be the favor to hybrid electric vehicle. So people start compensating their needs to start switching to electric vehicle, and still you can compensate the range and all. That's fine, instead of going with the full petrol vehicle. Yeah. So this is something people I keep insisting. You don't want to know only the technological part, right? Always find a good balance between knowledge and the practical aspect, right? What I mean by that is, usually people work on only projects, academic stuff, but it's also very important to know what is happening out there in industry, what kind of trends is going on. Make sure you be in line with the industry. Don't expect the industry to be in line with your profile. That never happens, right? So that's how I want to give an insight of what actually happens in industry, so that you get the idea of, okay, my profile, the same profile, there is not too much of variation in it, but the same profile can be modified in a way that industry can understand, and potentially they could recruit you for their development work, right? So usually we classify work into three divisions. One is preparing, another one is solving, another one is automation, right? So what happens in preparing is, it's same like cooking. You want to have finest vegetable with the perfect structure, and you start preparing it. You take unwanted parts and clean it up, and once you prepare your vegetables, you put it in and start baking out. You prepare it, right? So, and you get your final meal. Similar here, if you miss any one thing in preparing or solving or in serving out, you will entirely miss the flavor. Clear? So similar to that, there's a different role of engineers in a company. It's not that one is having a more weightage on other. No, it's never, right? So people who work on modeling and simulation, they specifically work on MATLAB and Simulink. They're trying to model the physical model-based design, say be it a vehicle, be it a controller, be it a design, everything has to be modeled in a system, and you perform set of simulation to actually validate the model. So what I mean by validate is, say you're going to 0 to 100 kilometer, you've done some ad calculation, you're going to verify with the software. That's kind of a modeling and simulation engineer. So this engineers who's is going to be the key role for the development process. The kind of a profile that usually we expect for the modeling and simulation is having a very great knowledge about electric vehicle, not a very advanced one, very great fundamental knowledge, and they're trying to apply something on practical, right? So at least they might have developed a product or something, or it could be a real-time application that you could do in simulation software. And second position that you get from electric vehicles are motor design engineers, right? It's specifically to torque and development. Say a particular product, a car, a SUV needs some amount of torque, say 2000 newtons of torque. Now you will be given a target to work on. You have to design the motor, sprocket, sorry. So motor, transmission, in order to satisfy the need of a driver, right? The top speed, all that matters in this particular domain. And third major domain is battery management system. So this is one another crucial system that actually involves in designing and developing a battery, right? So that's something keeps attracting everybody's in industry, because inevitably when you develop an electric vehicle, what you will be doing is without battery there's nothing, right? So if you don't have a charge, it doesn't make any sense to have a good motor, good transmission, good shape structure, right? So most of the research and development work goes in developing a battery. And PCB design, you want the controller to be the best at it. You don't want to get a lag or something whenever you drive a car. That's why most of the preference is given to these four engineers who's working on only single role. You will not be given very vast multiple tasks when you get into the engineering domain or research and domain, but you will be given a very pretty decent amount of work to actually showcase your skill. Right? Yeah. So we're done with electric vehicle segment. So do let me know if you have any doubts. We are moving to autonomous industry, and we're going to talk about what are the pros and cons in that particular industry. So before that, I'll show you some slides. Okay, I have it here, but anyway, that's why. Yeah, so do let me know if you have any queries that we could possibly address. So I see two guys are raising their hands. So if possible, you could drop it, or if you don't have queries, I think we can proceed further. Yeah, if possible, you could chat, or you could unmute yourself and you can speak. Aditya and Vikas Kumar. All right, I think we can. Yes, sir. We can proceed, right? So they don't have any queries to solve. Okay. Yeah. So before getting to autonomous industry, let me actually give you some points in electric itself, right? So yeah. So these are the what we call as a pyramid approach. This pyramid approach, we're going to tell you what are the major focus on electric vehicle, what are the least focused areas on the research and development vehicle, right? So we'll start with the cell. So cell, in the sense, we are extremely dedicated to a work which is related to battery management and stuff, right? So start from BMS, cell development, power electronics. That's a preference is highly given, right? So very least research and development areas are transmission systems, electrical motors, right? You develop a motor. So why is that? As I talked about this earlier, you start the BMS, right? You want the charge to be in the car, but rest of the part like transmission, electric motor, they are like accessories or add-on in your product, right? So remember, if you want to work on any particular technology, start with the battery management system. You have to have a baseline understanding on it, then you can go climbing the tree here. Yeah, so this is very, very important. We call it as a game changer of electric vehicles in automotive industry, right? So let me put it this way. Just think of tomorrow, I'm going to give a free electricity to everybody, and free electric vehicle, right? Just think of a government is announcing a scheme which is actually promoting a free electricity and a free electric vehicle, right? So do you think over a period of 5 to 10 years, maybe in a time span of 5 to 10 years, do you think electric vehicles still be implemented in India? Is it possible? for next 5 to 10 years, still giving the electricity free, is it possible that you see everywhere people are using electric vehicles? Is it possible at any scenario? So do let me know your comments. I'll be happy to hear from you. So if you have comments, try to put it on chat box. So do you think that India will be growing in electric vehicles for next 15 years if given a free electricity? Because I said electricity is a big problem. If you keep burning the coal, you keep polluting it. But think of, there is so much of wind is happening, there's so much of sun is shining. Usually they don't happen, but think of a lot of solar panels are there, sun is extremely shining, and you get so much of energy, similar to wind is blowing very high, and you get too much of electricity, right? So now, is it possible for India to keep developing sustainably in electric vehicle? Is it possible or not? Or in a range of 0 to 100, what is the possibility of developing it? You can take either way. Okay. Everyone. So you can directly put out a message that if you think that it's possible, or if not, then you could give a command. All right, it's not very possible, right? So think of this way, everybody is getting a free electricity and electric vehicle, but without developing a good storage element, there is no need of giving a free electricity. What I mean by that, so everything is down to the battery here. So you see here, these are the minerals that you see in a regular battery, start from magnesium, lithium, cobalt, nickel, everything, right? What usually happens is you have to store the energy to get effectiveness of electric vehicle, right? The only problem that usually we face is the minerals available in these resources, in this column here, right? So let me put it out this way. Magnesium, lithium, cobalt, nickel, the only problem is the cobalt. So why is that? Cobalt is the extremely rarest mineral available in the earth, right? This is very rare and it's quite expensive, right? So think of this way, anywhere in India you see, always these are two guys who's doing this battery manufacturing. One is Panasonic, another one is a Samsung, right? Whosoever is want to make a battery products or any electric vehicle products, anyway they have to purchase from them. There's no other option. So think of this way, whole country is getting electrification. Everybody has to start asking battery minerals from Panasonic and Samsung, which is not a reasonable way of dealing with the development, right? And this is going to be the great problem for India. What's the problem is going to be? You're going to soon, if you spread the electric vehicle, you obviously run out of cobalt, right? So look at it here. At 2022, 2021, we are here. The usage of minerals, because the selling rate of electric vehicles is very less, that's why usage is very less. In 2030, look at the range of minerals that used, because people start buying so much electric cars and you run out of minerals because they are rarest minerals, they are not easily available, right? So you see here how much percentage of total minerals are generated in a year. You see most of them is not from India, Canada, China, Cuba, Madagascar, everything is apart from India. So what's the problem is going to be, once you start spreading electric vehicles, you will be running out of minerals that's available for the battery. If you don't have minerals, you don't have a good battery. If you don't have a good battery, you don't have a good sustainable electric vehicle. That's the biggest problem. If you want to work on electric vehicle, try to find a solution for this. Replace the cobalt, replace the minerals of a cobalt, put any other mineral, and still the efficiency and the mileage of a battery has to be seen. That's a challenge that actually we are dealing with. This is known for every development company, be it Tata, be it Mahindra, everybody knows this. They're actually working on it, but engineering people actually don't aware of what's going on. So there's still kind of a lags here, right? So take care of this particular part. It's quite effective in developing a product in electric vehicle. So this particular slide deals with all the questions that you have in electric vehicle. So I'll be specifically talking about MG Lattice. So Morris Garage has developed this Lattice concept, back in their foray in Indian industry, right? They are set up in Andhra industry. So what is this? Is it comes with all the proof of shock, rust, and water restraints, right? So they have this short-circuited one. So a lot of questions keeps coming. What if my car is getting drowned in a water, in a rainy season? What will happen to my car? What will happen to my battery, right? So to put full stop for all the question, what they developed is they developed something like a 5 standard mark. So they have a European mark and they have a Euro NCAP. So Euro NCAP is a universal seal for safety and development of products. So if you have that, then your car is quite reliable. People used to buy that, right? So this 5 key standard is a key principle. To achieve this, you have to anyway work it together, putting all the money on research and development. That's why you see most of the advertising is not done too much, because they put all the money in research and development, right? So about charging station, no more, there is no worry of charging station. What usually people do is they are planned to implement almost 20 to 25 centers of charging station, both AC fast charging and DC charging all over India, right? This is a planned area that they managed to do it, right? So no more there will be a charging lag, charging time, and charging ports and stuff like that, right? But there is a question, there is always a consistent amount of question from the public to the automotive industry. That is, if you have a bike, if you have a two-wheeler, if you have a three-wheeler, what is the technology that everybody's working on? Is swappable battery, right? So what do we mean by swappable battery is no need to wait for to get charged. You go to a charging station, you swap the battery, right? So it's only applicable for two-wheelers and three-wheelers, where the battery size is quite smaller. But the biggest problem is your four-wheeler battery is itself a floor plan. Your floor plan, the floor plan that you have in a car, or the base plate, what we call it as a base plate, that itself is supported by the battery pack. It's really impossible to actually remove the battery and swap it out in a four-wheeler. And that's the biggest drawback, except four-wheeler. For trucks as well as bikes, three-wheelers, motorcycles, except four-wheelers, everybody have an option of battery swapping. That's the biggest problem, and you know that, right? Everybody knows that, and they are working on a solution. That's why charging station matters only for four-wheelers. It's not matters too much on two-wheelers and stuff, because they can easily swap it out. So if you are an engineer who's interested in electric vehicle, look into this problem, because swappable option is only for two-wheelers, three-wheelers, and even for trucks they have a swappable option, but four-wheeler you can't, right? Yeah, so we're going to jump into a new different topic, that's nothing but electric vehicles, right? So in electric vehicles, you have something called as autonomous driving, right? The only need, as like told electric vehicle, the only need of autonomous driving is very simple: to avoid human intervention in driving. Because a lot of times, I think if you take a graph, there are so many people who has died out, in road accident. If you just compare only in India, right? Then somebody gave me statistics. The beginning of Corona period, the way they were so much spread of the virus, right? So there's a clear statement from the traffic department that there's so many people are dying in road traffic and accident than Corona period. Due to coronavirus, right? So this is completely very serious issue, because there are a lot many problem associated with it, right? A lot of road accidents are keep happening. So to put an end to it, what usually we do is we develop autonomous system. So it's purely driverless car. You don't want a human to do anything. right? So in that we have 5 classification, right? Level 1, level 2, level 3, level 4 and 5, right? So level 0 is driver only. So driver do all the work, braking, steering, everything is done by him. Driver 1 is assistant, right? It kind of give you, say you're driving the highway, you just slipped off, it kind of give you a warning that, you're kind of changing the lane or controlling the steering, something like that. So level 2 is partial automation, where you don't want to touch the steering, and if it is a highway, it automatically take you to a left and right, and it detects that in the left there is a car, right there is a car, you have to go this way, right? So level 3 is high automation, where automatically it brakes, automatically it steers, automatically it controls entire system of your car, right? So level 4 is full automation, where there is no need of any driver intervention. Driver can sit back, relax, only you want to put the start and stop of uh, where you want to go, right? So it's very crucial to develop this. Somebody told me it will take minimum 15 lakh or maybe more than that, depending upon the range, but it will take minimum for any company to develop autonomous car. They have to at least drive for maybe 80 lakhs to 90 kilometers, right? So 80 lakhs to 90 kilometers very higher, but to develop a product, they have to drive and test it that much far to actually validate it, right? For India, most of the car, I think 99% of a car, they are level 2 and level 3 automation. They are still in that stage. Most of the cars are level 2, right? And a lot of cars are keep on upgrading. Like a lot of jobs are coming out in automation because they want everybody to move towards automation. That's level 3 is going to bring for that. So this is a methodology they use it. So whenever you see a picture, you try to classify it to a matrix form, into kind of a squared form, and you try to identify. You see this dog with a cycle, right? So you try to give it to the system, but system doesn't look the same way that you look, right? You look something like this, and it kind of classifies the area into different color. It codes differently. At the end, it detects that this area is dog, this area is a bicycle, and this area is going to be a van, depending upon how you go. That's why artificial intelligence and machine learning is going to be the key, right? So you see here, it only detects that if you have 2 limbs and 2 legs, it automatically detects that you're a human, and it kind of show you a different colored object, kind of a skeleton, to approach that. Whenever you are in a road, pedestrian crossing the street, it automatically detects that what actually you're trying to do. Yeah, so this is kind of a very important slide that I'll talk about. What's job market here, right? So every year we try to post around 60,000 job, which is not manufacturing, not sales, not non-technical job. I'm talking about pure technical job, right? And how much do you think it's going to be filled out? Most of the part is filled by the government, universities people, because they have a good reputation, academic skills, all stuff. And rest is going to be the IITs, BITS, most of them, because they have their reputation, and they do real-time product instead of so much on theory. And tier 3 are top tier private universities, and tier 4 are down like tier 4, tier 3 universities, right? So how do you bridge that? The only way is working on industry relevant products. What I mean by that, everything is set, everything is in theory, but when you convert your theory into practical, you will see that there is a very huge difference between reading and applying it, right? So that's why you always try to tell you, always work on real-time products. Don't learn too much. You obviously you need theory to actually start working on, but once you start keep on working on, you actually forget over a period, right? That's why a lot of people keep asking me, should I keep learning theory all the time? No. Once you are in industry, you are no more expected to learn any theory. Nobody will even I've been in industry for such long years. Only entry level graduate will be asked theory, but once you're getting to move on the career, nobody's going to ask you a theory. Eventually, down the line for 5 to 6 years, if you work on industry, you will end up in forgetting it. That's absolutely fine. It's human nature, right? So you forget everything, whatever you learn. But what's all the more important is, if you don't know something, if you don't know what is testing a diagram, if you don't know what is Poisson's ratio, then you should be able to find it out. You know where to find it out. That's very important.
Srinivasan sir.
Yeah.
Sir, actually we have only 12 minutes left, so please summarize your PPT. Yeah, we have only 12 minutes left, so set your time for presentation. Yeah.
Okay, okay, I get it. Yeah.
Yeah, yes.
It's almost
Because
done.
we have a question answer session also, including this 12 minutes.
Right.
Or,
Well,
sir,
I think almost done. Yeah.
Yeah, sir, please on your video, sir.
Okay, I don't have my camera inside here. I don't think it's going to be working, but let me give it a shot.
Okay, okay.
Yeah.
Please continue, sir.
Yeah. So I think we have only a couple of slides left. I think we'll not be taking too much of time.
Okay.
Right.
Okay.
Yeah. So the only way to match it out is working on industrial relevant project. Right. Again, if you think that CGPA matters a lot, never CGPA matters here. What matters here is I've seen a lot of recruited people. I've seen people who is having very less CGPA, but somebody who has done enough work in the field. Know the topic, know the job post, and see if you can be applicable to there, right? So remember, only way to get placed in any company is improving the skill set. There is no other shortcut towards it. Improve your skill set in that particular tool or a knowledge in that particular area, and try to prepare a good resume which actually correlate the job post. You read the job description, on a fair note, say Maruti is hiring an engineer. In a description, once you read it, you will be able to figure it out. Okay, they are looking for someone in this idea. Now you have to prepare the resume. Don't do the other way around. You read the description, you read all that they're asking to you, and you start acquiring skills or making up the entire format of your resume. That works pretty well, right? But again, only way to land in research and development work is to gain skills. There is no other a foul way of doing it. I think we're almost done. We are left with only I think 4 slides. Let me wrap it up. Right. So if you talk about autonomous industry, there are two major players in all over the world. One is Tesla, who's recently moving the entire automotive industry. Another one is Google's Waymo, right? So these are two different industries that pushes a lot on autonomous driving, right? So if you have time, that try to read the specification and learn. Okay, they use different sensors, radars, cameras, and stuff, right? Which will be helpful if you are actually interested in developing driverless futures and products, right? So put it on summary way, automotive industry is broadly classified. What we call it as a CA industry, computer aided engineering is broadly classified. On the first place, FEA. Under FEA, they have different field. One particular team in a company works on structural durability and reliability. So they basically address the issue of strength, durability, and stuff. And one another industry is fatigue industry. That's again very big industry. So fatigue industry is majorly focus on lifetime of products. Say you have a pin. You try to keep moving the pin up and down, up and down. In the time your pin fails, right? So you find the spot of failure, and again you try to do any modification such as giving the thickness, increasing dia, anything you can do. That's one other industry that's called a fatigue industry. And third industry is crash industry. So third industry is going to be a crash industry where basically looking for the crash and see what's happening in the vehicle, driver safety, all the stuff. And fifth industry in FEA itself, we call it as a durability, right? We try to calculate the durability stuff. So usually HyperWorks, HyperMesh, and crash. For crash, we use LS Diana software. Once you start knowing it, you will obviously end up in getting to it. But again, remember, software is not the end goal. Always remember, concept is the end goal. Don't try to learn the software, because Once in the 5 years, software keeps on changing, but sustain diagram will remain same. Poisson's ratio will remain same. Young's models will remain same. Only the application keeps changing. Don't try to master the software, master the concept, and try to implement the software and try to understand what's going on instead of pushing the buttons, what's going on behind. So if you understand that, whatever the software keeps changing, you know what is the strength of material, what is basic physics, and you can keep applying and changing the tool. It's similar to CFD. You have you can simulate the flows, external, internal, either aerodynamic or internal flow. Right, similar to that, you can do high inflow or low inflow. But from the point of view, design engineers are little bit lowly paid compared to simulation engineers. Simulation engineers are high in demand usually, right? And multi-body and subsystem usually, they do because FE is static. Static in the sense things are not actually great in moving, right? But multi-body, be it vehicle dynamics, be it a development of subsystem, they actually deal with a dynamic system of a model, which is actually extremely complex. So widely used softwares in multi-bodies are Adams, MSc Adams usually used, and very less people uses motion view, motion solve, right? So these are the most widely used domains here. Again, one another thing is very important here is don't choose industry depending upon salary package that you and what is the scope. Never do that. Just go through your engineering subject after your graduation and see whether you like strength of material or kinematics of machinery, whether you like heat and mass transfer or thermodynamics. So depending upon that, try to connect to the industry too. If you like thermodynamics and heat transfer, then the area that you want to go is CFD. If you like strength of materials and kinematics of machinery, then the area of interest is going to be FE. If you like engineering, drawing, drafting and stuff, then you have to go to design. First, find the field of interest which is applicable to you, again subjective, and then try to go in. A lot of people do the same idiotic thing. They say that FE is getting highly paid, so that I'll go there and I get highly paid. No, it's purely a knowledge driven and idea driven. Hope that makes sense. So the final slide, we are going to just bring a SWOT analysis in industry. Just I'll divide into two parts. One is North Indian industry and then South Indian industry, right? So they both have a different way of working. South Indian industry are majorly focused on manufacturing. Back in Chennai have only 15 research and major 15 research and development, which is like DM, Toyota, Ford, and other that. But most of the companies in Chennai, they do only manufacturing. They don't actually develop it. But the guys, 20 people who's developing the product, they develop it at the best. There is very less startup companies in Chennai who do automotive development. But on the other side, what happens here is North Indians have North division have a lot of startups, a lot of CAD startup, a lot of things they have tend to do a great way, right? But they do have a decent amount of, Pune have a very base of research and development, if possible, try to get it in there and basically try to work as an intern and try to gain as much of knowledge. And I'll prefer to work for free, because once you want to get the knowledge, right? Anyway, work for anywhere who's going to give you a great knowledge. But remember, don't be in a place where you're not actually doing a research work or development work, because the huge portion of development is going to be coming once you do it, right? So try to be in an area or get trained in an area where somebody is actually developing a product via simulation or validation, right? So that's kind of a summary that I want to put together, right? So I hope this particular slide is going to deal about what are the things that we develop in industry, say similar electronics, engine components. So you saw huge amount of engine components coming from India. All that needed is going to be manufactured in India, and other than that, very few is coming from outsourcing, right? So remember, all the engine and driver and components are manufactured in India. Anywhere you see, you get to see that particular component. Yeah, hope this session enriched with your right amount of knowledge that's needed to be in a research and development engineer, right? So yeah, so that's the end of the session. I hope you all enjoyed. Yeah.
Okay, Srinivasan sir. Thank you for Srinivasan sir. Now I invite Mr. Tejkan sir for vote of thanks and question answering round. Please invite Tejkan sir.
Sir, Good afternoon, sir. Sir, I have one query. Sir, what are the basic and essential needs to join the research and development industry of in automotive sector?
Yeah. So this particular question, I think it's quite subjective. What I mean by subjective is automotive industry in general is very bigger,
Yeah,
right? But
yes,
if you want to address the same question in a different way, say, I'll answer this is from only one question. Say,
yeah,
if you
yes,
get into mechanical industry,
yeah,
who develop products,
yeah,
right? So to answer that way, first is understanding the theory so well, right? Say a simple example is we have a beam and we are trying to do a company can do something on the beam, but you have to know what is the stress strain diagram, what is stress, what is Poisson ratio, all that. Once, because engineering graduates are expected to know that. That too, if you're not fresh, if you're not experienced guy, engineering graduates are known for the theory knowledge, good in theory knowledge, and the practical application of that. So what I mean by practical application is you want to know why the test is conducted and what's the outcome of the test. You have to interpret that. That's the first thing. Second thing is know something about the industry, what they are actually doing. Say the tools they use, the software tools they use. I'm not saying that you want to have so much great knowledge on the industry tools. That's also not possible. That's
yeah,
why 90% of industry, be it Mahindra, Maruti,
yeah,
whenever they hire fresher, they train the fresher.
yeah,
Like minimum training period will be 5 to 6 months.
yeah,
But you want to, kind of give a confidence to the hiring manager that I am a guy, I can be trained. That confidence is needed for any graduate, I think, who's coming out to be working in a research and development, because all that, even I'll whenever I sit in an interview panel, I'll be looking at a guy whether this guy will be capable of giving a training and I'll be able to get the outcome.
yeah. Oh, okay, 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 sir. Thank you, sir, providing such wonderful and wonderful knowledge about the current scenario of the automotive industry. So it gives me an immense pleasure to deliver the vote of thanks to Mr. Srinivasan sir for providing the wonderful knowledge, and also I would like to thank Dr. Sanjeev Kumar Gupta sir, Dean of Faculty of Engineering, and Mr. Vinay sir, HOD of Mechanical Department sir, for coordination of the workshop. I also like to thank all participants for listening the session, and all faculty members of mechanical departments. I would like to thank Mr. Manish Bharti sir, co-convener of this event, and help me to organize this session. And finally, again, I would like to thank Mr. Srinivasan sir, spending the available time for us, and giving us such knowledge, learning information. Thank you, sir.